What is discharging a capacitor? Discharging a capacitor means releasing the stored electrical charge. Let's look at an example of how a capacitor discharges. Imagine a water tank filled to the brim. Opening the tap allows water to flow out. Similarly, a capacitor discharges when a path is provided for the stored charge to flow. The capacitor, a brief overview. A capacitor is an electronic component that stores electrical energy in an electric field. It consists of two conductors separated by an insulator. Think of it as a tiny battery that can quickly charge and discharge. How does a capacitor store charge? When connected to a power source, one conductor in the capacitor accumulates a positive charge, while the other accumulates a negative charge. This creates an electric field between the conductors, storing the energy. The discharge process begins. To discharge a capacitor, a conductive path must be established between its terminals. This allows the stored charge to flow from one terminal to the other, neutralizing the electric field. The role of resistance. The rate at which a capacitor discharges depends on the resistance in the discharge path. A higher resistance slows down the discharge process. This is similar to a partially opened tap controlling the water flow. Time constant, the discharge pacemaker. The time constant, represented by the Greek letter tau, is a crucial factor in capacitor discharge. It determines the time it takes for the capacitor's voltage to decrease to about 37% of its initial value. Exponential decay, the charges fare well. The discharge of a capacitor follows an exponential decay curve. This means the voltage decreases rapidly initially but slows down as the capacitor empties. Applications of capacitor discharge. Capacitor discharge finds applications in various electronic circuits. Flashlights, cameras, and defibrillators utilize this principle. They store energy efficiently and release it quickly when needed. Safety first, discharging precautions. Capacitors can store significant amounts of energy. Always discharge a capacitor before handling it to prevent electric shocks. Use a resistor or a dedicated discharge tool for this purpose. Conclusion: capacitor discharge unveiled. Understanding capacitor discharge is essential for electronics enthusiasts and professionals alike. By grasping the fundamentals, you can effectively utilize capacitors in your projects and ensure safe handling practices.